Hello, everyone. And so our next talk will be about difference that we could met in different type of browsers and browser engines that we could use in our automated tests. And we'll know this from David Burns. His great experience on this topic and currently from present browser stack, and also has even great experience from magical Mozilla. And I will be expert on this talk. So my name is Dmitry Kurkin. I'm more from development side as developer, and also probably known with some talks on this topic. So, David, small question before you talk. Aren't you a bit? Do you have a bit of responsibility that you could scare somebody with all these issues with all these differences in platforms? Maybe somebody decide that's maybe not try to automate, maybe try it with raw hands.
Yeah, so this talk is definitely not designed to scare anyone. The talk is designed to give you is to educate and give you ammunition in moving your job forward. It has examples from different projects where things have gone horribly wrong. I will even make a reference to a company who had a lawsuit because of these differences, and it cost them money. Obviously, I won't go into naming companies, because I think I don't want to be sued myself. But at least if I know these stories are all real, I'll show you real examples. It's not supposed to scare you, but it allow you to kind of create a different risk profile when you're looking at who your customers are, who everything is, and then from there, you can make decisions. But it's not supposed to change any of. Well, it might change one or two people's thoughts, but that's about it.
So sounds quite promising. Let's then begin the slide with the talk.
Yeah, let's go. So, hi everyone. My talk is called Why Browser Engines Do Not Equal Desktop Browsers, Do Not Equal Mobile Browsers. My name's David. I am the head of the Open Source Program Office at BrowserStack, and I've worked for Mozilla, as Dimitri pointed out. I'm the chair of a W3C working group to do with browser testing and tools. And so I have a lot of knowledge in this space, and I'm hoping by the end of this talk I would have shared some of this knowledge, because I think it's better to share than to have it all in my head. So this is the agenda for today. I'm going to talk through different levels of what I think is important. We're going to start with specifications. The specifications is really just one specification. Then we'll talk what I consider levels of real user testing. There are tools out there that kind of lie when they say about these things. Then we'll go into headless, headful. They talk about browser engines versus real browsers, mobile browsers versus simulated and emulated browsers, and then hopefully at the end there'll be some time for a Q&A. Cool. So, as I said, we're going to talk about specifications. And specifications are what kind of drives the web. It allows us to be able to use Chrome, Opera, Firefox, Safari, and anything in between, right? And especially nowadays, there are a lot of like embedded browsers that are arriving on the market, or people want to kind of change things up. And so it's good that you have these specifications to allow us to build our web applications with the confidence that you write it once and it works everywhere, right? For years, Java was saying that was the truth. It wasn't always the truth and was very bloated, but the web is truly that write once, run everywhere belief. And all specifications all over the world really come back down to this one, which is RFC 2119. And what this RFC or this specification does is it tells us the meanings of certain words. So the keywords here, I'm not expecting you to read this whole wall of text, but the keywords here are must not, should, and should not. Now, if a specification has must or must not, that is written in stone. Like it needs to, like whatever data comes in, and if it says it must come out this way, you can't go against that, or it must not come out like that way, right? It should be said that way. The problem is if people start using should. If I send this data in, it should look like this at the end. Should and should not creates interpretation. And this is where we get those weird and wonderful bugs in like JavaScript engines, in renderers, in kind of in HTMLs and things like that, is that there was a time where people said this should do this, and it created all these things. And that's where you would get these differences between Internet Explorer, Edge, Firefox, Chrome, and Safari. So it's really, really important that we focus down when we're creating the web down to the must and must nots. Anything else just creates a wild west, which is not good for everyone. And so when you're thinking about all the things that I'm going through, just remember these must and must nots, because it's kind of like there's probably somewhere in a specification where this has not been followed, which has created a lot of these scenarios. Okay. So, real user testing. Now, I'm sure a lot of you out there, when you're doing automation, you want to emulate real users as much as possible. And the reason why it's really important to emulate real users is that when people test their application, that you get the right feel for things when you do things. And it could also lead to some security in your application by making sure that it does it. Now, Selenium, Playwright, their focus is on kind of driving the browser from within, which then creates more real user testing. If you have a testing framework that injects JavaScript into the page to kind of do the things it wants, to fire off events in specific ways, you're not going to get that real user testing, which then creates these scenarios that we're going to go into in a bit, where we're not creating the right way. And a real world example of real user testing is if you have a login screen, when you tell your automated test to type in characters into the text box for your username and for your password, you can check if it's coming from a real keyboard or if it's being injected via JavaScript. If it's being injected via JavaScript, there's a high probability that someone could be trying to spoof to kind of capture data and then re-inject it somewhere else. And so in the real world, you would want to block any type of that. Same with a click and a submit button. You would want to do this. in the real world, there's like in the browsers, there's this event, like whenever you're doing these events, there's a property on that called isTrusted. And the way the isTrusted event tends to work is that it looks to see where it thinks the event has started from. If it thinks the event has started from deep within inside the browser, and so the page has no concept of what is happening to it, then it will think it's trusted because it's come through the event loop. The event loop could be the browser's event loop, or it could be the operating system's event loop. It comes in, it goes, it's trusted. And it's important that we know these things, because if we try to create these real world scenarios, then we're giving our users a better outlook on how we're going to do things. And we don't get these scenarios where we're doing 1 + 1 = 3, which is not good. We want to be able to trust what is happening within the browser at all times, right? That's the whole point of this talk, is that we want to trust the browser to do what we want. It's the same with if we had a login test. Login tests are my favorite, by the way, because they can tell you if a tool is good or not. If you start at HTTP and you go all the way through, can your tool survive that test? So HTTP needs to go to HTTPS the minute you need to send data across the wire, because it should be encrypted for security reasons. You need to check that events are trusted and that it's doing the right thing. And so why does this matter? Because the main thing is that a lot of tools out there are comparing, it's not there, comparing themselves to kind of browser testing tools when they're just kind of starting up a browser and putting it through. And so when we get into later, harder scenarios, if you're not doing the simple things correctly, the harder things are going to be even more incorrect later on. And so now I'm going to start going into start diving down into the browsers, because we started specifications, we started at the document, we moved on to the document. Now we're going to go into the browser slightly. And we're going to start with headless versus headful testing. Headless testing was kind of created a very long time ago, long before Chrome put it with Puppeteer. We had things like Slimer, Phantom.js, HTML unit, HTTP unit, and things like that to be able to kind of test our applications. We even see it nowadays with other tools like JS DOM. And so a lot of headful and headless testing is important in different scenarios. As a developer, I don't want my screen taken over when I'm testing something. I want to be able to kind of like write some code, run it. It can run in the background without taking any of my focus. I can then carry on seeing if my test pass, and then while carrying on looking at the code. This is how I like to work. When I go into my CI, I want it to be headful. I want it to be kind of using a real browser, because there are going to be differences. And the differences can be huge. So for years, I was told that I was wrong, that the headless mode in Chrome is just as good as the headless mode in headful mode of Chrome. It turns out it wasn't. Matthias, who's a brilliant engineer, heads up a section of the DevTools team in the Chrome, and they were not happy with it, and they got rid of the old headless Chrome, because essentially it was a different browser. How different? I'm sure you're wondering. it didn't use any of the same code paths that the Headful browser. And so when you're rendering a page, I did a talk on this in, I think, 2016 at Selenium Conf in London. So it's up on YouTube. But I'll give you a short version of it, which was whenever you render a page, you get all the CSS, JavaScript. It gets to a point where like the browser thinks it's okay to start rendering. And this is all happening in milliseconds. So it's like super fast. It then generates these lists called a display list. It sends that display list to the operating system, it renders it. The way the Chrome Headless was working was that it was doing all of that stuff, but the way it was generating those display lists was very different to the way that if you loaded that web page in Chrome itself, there's a potential to look different. Again, you're probably wondering, why does this matter? Because when you're coming to real user testing and things like that, you're not getting that real world experience that your users are wanting. And so it could create opportunities for things to go wrong. Now, I'm sure some of you do visual regression testing. It's really important nowadays because you can kind of spot those little differences in different browsers. You can also spot like accessibility problems very quickly through visual regression testing. Chrome, the old Chrome Headless, its color palette was very different to Headful. So if you're doing visual regression testing, you would probably get a number of like mistakes suddenly crop up. Or like this doesn't look how I was expecting, or things like that. So it suddenly breaks down very quickly. And it leads to a situation where we're actually comparing apples to oranges, or apples to lemons, or oranges to lemons, peaches. And so I'm sure you get the idea, is that you've got all these things. Now, I know I've started by kind of attacking Chrome. The next question that I would expect from people is, what about Firefox? Now, Firefox would have slightly different in some scenarios, but the way Firefox does its headless was that it would render everything invisible. So it would hide the window. And so it was still going through all the same code paths, except for some scenarios where like it's very hard. So like if you want to do file uploads or like anything that needs to interact with an operating system dialog. So file uploads is the easiest example of that, where then those scenarios wouldn't work, but for everything else, it would do it. And so this is like I'm sure you've seen it where you've been trying to set up your CI infrastructure for headless mode, but you still have to set up like an X virtual frame buffer, XVFB, on those machines just to be able to kind of do these things. So it should, that's an example of it. So now I'm going to move on to browser engines versus real browsers. And this is where I think it gets a little bit more interesting, but a lot more nuanced, because people go, but it's the same thing, right? Is it the same thing though? Right? We have Opera, Brave, Chrome, Vivaldi, and so on, right? Like we've got all of these browsers. If they're all the same, why do we need to change? I can tell you that Brave on a web page is going to react very differently to Chrome on a web page. Some of it's for security, some of it's for cookies, some of it's for other things. And so they all have these like little kind of quirks. Everything is built off Chrome, but it's Chrome at a specific point in time. I know, like Brave, I think I haven't looked at Brave for a while, but like Brave used to only update, I think it was once every 2 weeks. When I was last speaking to Edge engineers, they were updating every 2 days because it's a lot of effort to kind of update their code bases. And so there are going to be quirks, but they're also going to add in their kind of unique selling points, like what makes Brave Brave, what makes Edge Edge, and obviously Google are going to put in what they need to kind of support their Google sites wherever possible. And then with like Safari, we have like the Safari, we have the next version of Safari, which is like say a nightly. But people will tell you all of this is just WebKit. But if it's all WebKit and it's all working exactly the way people are expecting it to work, and so I can write my tests in one go and it just works, why do we get huge problems like this? So the Safari team made changes to IndexDB and it broke. The interesting thing with this bug is that because I like how it starts out, Apple's WebKit team has managed to break it, right? If you were using WebKit or like if you use say Playwright or Cypress and use their WebKit, you would never have hit this issue because it only happened in Safari WebKit. And it only happened on Safari WebKit on desktop. So now you've got this situation where you've got a real browser is breaking, a browser engine is not breaking because people can make the changes that they want along the way, which can be rather scary and off-putting. But like I say this as someone who's fortunate to kind of work on a Mac, but not everyone is fortunate to work on a Mac. I also know that you can't test on Safari if you don't have Apple device, which then makes testing on these things very hard or very expensive. Another example, because I like to find some weird quirks along the way, is that the draw image doesn't work with Webm files. So Webm is a media format that you can kind of put through Canvas. If you try to run this web page in this example on Safari, it worked. If you worked on Chrome, it worked. On Firefox, it worked. But only on Playwright's WebKit version. And for the most part, like the Playwright team, and for those who don't know, the reason they ship their own browsers with their product because they've made little tweaks. Their tweaks have got nothing to do with the draw image. It's more to do with like how you communicate into the browser along the way. So that like this shouldn't have done anything, but there was a little change in kind of between versions or the way Safari works. And so you got to a stage where you can do the playback or kind of do things with Webm, which is a new up and coming format that a lot of people are going to start using because it's lighter weight. And one of the key things that I'm sure a number of you, well, your web development teams, if you're not on the web development team, are saying is that like your products are going to be voted down if they're not using new technologies on search engines. This one I thought was quite interesting. Shared array buffers. These are heavily used in like WebGL and Wasm. So Wasm is the ability to take like a native a program in a native language, so Rust, C++, something like that, be able to transpile it over to JavaScript and allow it to work. This bug is nearly a year old, still open as of last week, but it's been working in Safari for a long time. And so we've got this situation where kind of people going, oh, this doesn't work. And now I've got to create these like weird and wonderful types of tests to make sure that things work. So we've seen the differences between browser engines and browsers and how they are very different. All right, and it's kind of it's those weird and wonderful quirks that suddenly creep up. We're going to look at like real mobile browsers versus simulated browsers. I'm also going to kind of, when I say simulated browsers, because I didn't want my slide going too big, I'm also including emulated browsers at that point. So COVID-19 saw the boom of mobile usage across the world. Like it, I've had to, at Browser Stack, I've had to speak to a couple of customers. I don't speak to customers that often. And there was one customer who, and I got them onto a webinar to discuss it, where they saw mobile usage, like users went from like 80% desktop to 80% mobile on their banking. But owning all the devices is really expensive. And mobile development is ridiculously hard. Like it shouldn't be this hard, but it is. Like I'm very thankful to DevTools for trying to make it a little bit easier. And we've seen it quite regularly where like Firefox or Chrome, I don't use Safari that often, but I'd be surprised if Safari didn't have it, the ability to kind of shrink your browser to emulate what you want. And then, but then if you want to test it on a device, even if it's just your own device, right? Getting that set up useful is very hard and painful because like you're working on localhost, you then have to kind of expose localhost and your machine to the network, and you have to go through all these layers upon layers upon layers of pain, which is not useful, and it's not good. However, as I said, like DevTools has made it not so hard, but I think in going down that road, they've created some scenarios that it creates things that we're not expecting. Because they were shrinking everything down. We need to know that resizing a browser, a desktop browser, is not mobile. And the main reason is that their operating systems and their kind of choices in that they make, their opinions in the operating system, are very different to desktop. I'm sure we've all heard that like Safari is the new IE because they don't want to implement all the APIs that Google say are important for the mobile web. But the one thing Safari has done really well is that it's focused on battery life all the time, constantly. So if you use Safari and you're scrolling the web, you're not going to see as many problems, or not problems, but like problems with your battery. The same can't be said for Chrome, or for Firefox. I know like both of them in the last couple of years have been focusing on battery and performance. But for many years, that was kind of a nice to have, not necessarily an important thing. And so if you've got some JavaScript that's running constantly or things like that, or kind of when you're shrinking it down, the pixelation on your screen is very different to that of a mobile device. So emulators try create this for Android. And so an emulator, for those who don't know, what it tries to do is it takes all the instructions and tries to like convert them between the like your desktop, your laptop, computer, CPU at a CPU level. So it goes like, I will pretend to be an ARM device, or that my CPU instructions are this shape. Then it goes over to an Intel device and it has to change it and try to do it. This is one of the main reasons why emulation is so slow, because not only is it doing all the like work that a phone should be doing, like like your application, it's now doing all these extra translations, and that's why it becomes really slow and painful, and really, really painful, to the point like people just stopped using them. Where like on the Apple side, Apple were like, we're only going to create a simulator. We're not going to do any of that stuff, but we're going to tell people that this might not be exactly the same, and you should at least have one test run on your device. And suddenly, like, it becomes very different. I know when I was at Mozilla, the number of like performance issues that people commented on, this could be from rendering to like JavaScript or anything in between. We had a number of performance issues that would crop up because we made assumptions, and because the browser, and this goes back all the way to the specification level, is it's trying to create APIs and smoothness across all APIs, so that if you're working on a mobile device or a desktop device or an embedded device, that everything should work together, right? Should being the operative word, and like going back to the specifications, we don't want should, we want must, right? But software, bugs do exist, and we need to kind of try highlight them to our end users as much as possible. But so we create these situations where we know desktop browsers are not mobile browsers, because the underlying operating system and the kind of the smoothing between the two is different. And here is this is probably one of my favorite bugs that I've spotted. And so I'm going to just point out that throughout this whole talk, I've only gone looking at Playwright because I know they have their own browsers and things. This is not an attack on Playwright. But here we have a situation where if you're on Mac and you try shrink the browser down to a like mobile phone size, and you put it onto a second screen that's not a retina display, your device pixel ratio is wrong. And a lot of like mobile apps and mobile web apps make a lot of assumptions based on what they can see through device pixel ratio. And so this is one of my favorites because it's like when you put headless and shrinking a browser and this into place, you don't know what you're getting, right? You're making assumptions, but because you can't see it, you can't do what real users are doing. then like we create these situations. And so throughout my talk, none of this was like, please use Selenium, please use this, please use that. It's to kind of educate you, to give you the tools to kind of make informed risk decisions. As I said in the intro, I know of one large company when I was working at Mozilla, because it came through the grapevine in the like the interoperability teams that I managed and things like that, was a large company was sued for millions, and the tech company lost because they were testing Safari using Chromium when Chromium was WebKit based. They didn't want to set up all the infrastructure to test, because it's very hard to set up Apple devices to do things. So it's very hard to go there. So they got sued, they lost because they were testing Safari through WebKit. And so sometimes it's worth it, sometimes it's not. But it's at least, now that you understand some of these differences, you can create some different risk management profiles. And with that, I think we're down to my Q&A. And I think that's it.
So, thank you so much, David. It was quite interesting to go through all this difference in issues. Unfortunately, currently we still not have questions from in the chat, but from my side, so if we have all these differences, all these issues with engines, with headless, so does it really make sense to use them? Maybe we'll try to use and like user devices or user browsers. Maybe use some platforms like browser stack instead of trying to run engines or headless.
I think the main one is obviously, like, I work for BrowserStack. We have all the infrastructure that you need, and so I appreciate it can come across as me trying to sell BrowserStack. That's not what I'm trying to do. The when I'm working when I'm doing development, I do things in headless mode, right? Because I've got it in here. I don't want to be distracted, and so there it's headless. The minute it leaves my machine, so it goes into a CI and things like that, I think at that point, the decision needs to be as close to what a user should be using, within reason, right? You can't test on every mobile device, because then you're going to need all the money in the world, right? Like not only getting the devices, but managing the devices. Managing devices is really hard because, like, if you keep mobile devices plugged in for a long time, the batteries can expand and explode, and like you've got all that. Not only that, you've got all the Wi-Fi problems that come up with it. So it becomes like it's this huge snowball effect of like becomes really expensive. Pick what you think is going to be the least amount of risk along the way. Make those decisions along it. And there's going to be a point where you like, well, actually, we can't afford this, we can't afford that. That's fine, right? But at least you've pointed out the risks to the people that need to know, and then you can go from there. Because there might be times where it's like, yeah, like we could just pay people back a year's like subscription to our service as a sorry, then kind of like have to pay out all that, build out all that infrastructure. So it's a risk balancing process.
And now questions from audience. So they ask, how often do people choose headless browsers over headphone? So based on your experience.
I don't. So it's very hard. Very vocal people will tell you headless is the way to go. And so you see it like with people using JS DOM to test their React apps, for example, right? Like that's a big thing. I don't know the number. I just know like a lot of vocal people do it. I've always been the person to go, well, kind of try use the real world, because like that's what your users are going to be using. Like that for me is the big thing. It's like use what your users are going to be using as much as possible.
And one more additional question to this topic. So, how many resources could we save with the headless? CPU and memory.
Yeah, so I don't think you actually save a lot of resources. The only resource you would potentially save is having to kind of like you can save a bit of memory by not having to have an X like a window manager. So like Windows X, things like that. You could probably save some resources if you kind of put it all on Linux and use the X virtual frame buffer, XVFB. You could probably save some resources. But again, like doing that, like you're saving certain things, but browsers are so complex nowadays. They're effectively operating systems. So you're loading an operating system into an operating system every single time. So kind of be aware of how that dynamic can happen. Because I know like there are people who go, oh, I'll just put like this one core and maybe like 500 meg of memory into this container, and I'll run all my tests there. And then they're like, wow, why is it so slow? Why is it so this, that, right? Like you've got two operating systems in this tiny little space competing, which is an interesting way to do it.
Yeah, and still more questions about headless. So seems it's for UI test and for end-to-end test, it's better to use headphone. But maybe you could recommend for each scope we still could use headless. So maybe for API test, or maybe you could mention some areas there it could be more useful.
Yeah, so for API testing, I would definitely never use a browser ever. As much as like, unless you really, really need to, I wouldn't be using a browser at all. And so in that case, it would be headless, I guess, because there's no browser. Like for component testing, I would probably have some form. I would have that as headful testing, but if I'm on my local machine, I'd have that headless. I think the main thing is to focus on the test pyramid. So kind of you have your unit tests, then your integration tests, then kind of like maybe component tests, and then your end-to-end tests. And as you go up the pyramid, you should be getting fewer and fewer tests along the way. Focusing on that, and then that way you like you shouldn't be running all your tests in a browser. I think a lot of people create too many, Playwright, Selenium, Cypress tests, right? In general, when they're developing, I think they should kind of focus on the testing pyramid. I did a talk a while ago where I noticed that people were doing what I call the the testing Christmas tree, where it starts out as a pyramid and then it gets halfway up and then it creates a new pyramid from there, spreading out again and then going back up. Or the testing hourglass in some cases, right? Like where it's a triangle on top of a triangle. So focus on the types of tests, and then from there, just create the scenarios that like, do I need a browser for this? Yes. What is my risk profile for these? So like integration type tests, your risk profile is going to be small, but your end-to-end tests, those should probably be on what people are using, and focus that way.
Yeah, and seems we're running out of time and should wrap up. So we have post talk where still other listeners could ask more questions. So we'll switch to it, and now we should finish and say bye bye to the audience.
Thank you, everyone, and thank you, Dimitri, for being my expert.
Welcome. So bye bye, everyone.